Welcome to single phase motors video part number 4. We are going to discuss about the permanent capacitor motor, and the same thing is known as permanent split capacitor motor, also PSC motor. Let us see what is happening. We'll be seeing the circuit diagram like this. There are two windings. One is known as main winding, the second is auxiliary winding, and a capacitor is connected in series to the auxiliary winding, and there is a squirrel cage rotor of the single phase induction motor. Now the supply voltage is single phase 240 volt being given, and for the phase splitting there are two windings, and one winding is connected through the capacitor. So the two currents will be flowing in different phases. What is it? So this is the auxiliary winding which is having current, which is a capacitive current or leading current. So let us see. This may be, if you are taking the sine wave like this or the flux like this, it will be flowing like that. And if you can take the current through the main winding like this, it will be having some lagging condition like this. Okay, so effectively the phase is getting splitted in this motor by the capacitor provided in the auxiliary winding. It is having some leading current, and the leading current produces revolving or rotating magnetic field, and hence EMF will be induced in the rotor, and rotor starts to rotate, as we have told the working principle in the video number 1 and 2. Now, because the capacitor is having a leading current and there is no centrifugal switch available in the circuit, you can see there is no disconnecting part. The auxiliary winding is permanently connected to the circuit with a capacitor, and that is the reason it is known as permanent capacitor motor. There is no centrifugal switch or there is no disconnection of the auxiliary winding. Okay, so it is known as PSC motor, permanent split capacitor. Also in the motors without the centrifugal switch, single phase motors without the centrifugal switch, the windings will be known as only main windings and auxiliary winding. There is no running winding or starting winding, because both the windings are used continuously, and we cannot tell it is one is starting winding or running winding, because it is entirely available during the entire the operation of the motor. Now let us compare the main winding and auxiliary winding. Both the windings will be almost similar with inductance, and a small resistance may be additional given to the auxiliary winding. Generally, few more turns may be in the auxiliary winding. Generally, both windings are interchangeable. In the motors like this permanent capacitor motor, permanent split capacitor motor, which is used in ceiling fans and all, you will be able to change the main winding and auxiliary winding, both the things, because the windings are almost similar. The number of turns and thickness of the winding also will be same, and the leading, it is decided by the capacitor connection only. Okay. So this is about the physical windings, and we'll be seeing the features. It is having very low starting torque. The PSC motors are having very low starting torque because the difference between or phase angle between the main and auxiliary windings are very less. So it is having very less starting torque. We can say practical condition, you are having a ceiling fan with you and you can keep it blocked even if you are switching it on. Before switching on, you can keep it by hand and it will be blocked, because it will not rotate, because it's the starting torque, it is very less. You compare some other motors like water pump motor with CSIR. If you are holding the shaft and switching on, what happens? You cannot hold it will be automatically running, because it is having very high starting torque. So we can compare the starting torque with other motors. The PSC motor is having very low starting torque due to the phase angle difference between the main and auxiliary winding, it is very less, and the power factor is comparatively high because it is having almost similar inductive winding and a capacitor. Because of the capacitor, it is having high power factor, and the advantage is we can easily change the direction of rotation. In this ceiling fan, we'll be able to change the direction of rotation easily. We'll be telling how it is used in washing machine in the later slide. It is a continuous duty rated motor. We can say the ceiling fan motor, table fan motor, it is there in the circuit in the full time operation condition, and that is known as continuous duty rated motor. And you can compare it with CSIR, capacitor start induction run motor. The capacitor will be available only during starting, so the price of the capacitor will be less, even it's having higher capacitance. The capacitance of the PSC motor is comparatively less, like 3 microfarad. Still it is made of paper type of capacitor, and the cost will be comparatively high with respect to the microfarad. The CSIR motor, which is used only the starting condition, it is used electrolytic capacitor, and that cannot be used for PSC motor. We have to use paper capacitor. The capacitor value is low, like 3 microfarad and all. Now, if the 3 microfarad value is available with the manufacturer, the technician should not reduce the value. If reducing the capacitance value, the torque also will reduce and the current will increase. Okay, the torque will decrease and current will increase if you are reducing the capacitor. So as a technician, if you are rewinding the motor, you have to use the same value of capacitor. And what happens if it is increasing? If you are using 3 farad capacitor and 3 microfarad capacitors, you are changing to 5 microfarad, the torque will increase definitely, but the speed may not be available to the right value. The speed may be reduced. So you should be, as a technician, you should be remembering that the value given by the manufacturer, you should be always be used in the capacitor. If you are seeing the torque value, you can see the torque speed characteristics at 0 speed or at starting. You can see only 50% of the rated speed, rated torque it is available. The torque will be very less, and running torque is comparatively good, and it is running almost 200 at 80 or 70 to 80% of the rated speed. Because of this, I just, as I told, you can even hold a ceiling fan or table fan before it is switched on. There is no problem, but pump motor cannot be held by hand because it having high starting torque. The permanent split capacitor motors are having lesser starting torque, and that is the reason it is only used for fan type of application. What is the load of a fan? It is the air is the load. To cut the air, it is easy, so less torque is required for that application. So wherever less torque is required, the cost is will be less if you are using permanent split capacitor motors are used. And the direction of rotation change in a washing machine, we already told the direction of rotation change, it is very easy. Let us see the conditions in this picture. Let us say it is rotating in one direction with these connections. Okay, so the main winding is taking a current like this, and the starting winding also will be taking a current. Let us say this is the current taken through the starting winding, and the starting winding current will be having a leading value because of the capacitor, and the main winding, not the starting winding, it is auxiliary winding. The main winding will be having a lagging condition. So phase split is there and decided by the capacitor. This is one way of rotation of let us say consider this is the original direction of rotation of the permanent capacitor motor, PSC motor. To change that in a washing machine and all, what you are going to do is you will be connecting like this. You will be just connecting one end of this line and it will be connected to the other end of capacitor. Now what happens? This area will be becoming just a auxiliary winding. As an auxiliary winding, the other will be becoming a main winding. How it is like a main winding? You will be able to see the supply is coming here to this winding and it is returning back. So it is permanently parallelly connected. That is the reason it is now main winding, and you will be able to see the other section is connected to the auxiliary other winding. Then it will be acting as a auxiliary winding with capacitor. So by just changing this connection to the other end of capacitor, the auxiliary winding, it is becoming the previous main winding, which is now leading. You can see now the winding will be having a current. This winding will be having a leading current with the capacitor, and we can say the other winding, the present auxiliary winding, will be having a current which is lagging. You can say this is the winding without any capacitor, and that will be having a lagging current. So what happens? The current in the U1 U2 winding, it has become now leading. So the direction also changed because of the leading change, and by simply changing a connection from this side to this side, it is changing the direction of rotation. This method of changing the rotation is used in washing machine with a timer connection. Okay, there may be a timer and the connection will be repeatedly changing either like this or like this. This connection will be continuously changed. The washing machine will be changing its direction of rotation. Okay, now the applications are as ceiling fan motors. It is used ceiling fan motor, and table fan motors and washing machine motors are being used with this permanent capacitor motors or permanent split capacitor motors.